Thank you all. First, I'm going to apologize for my voice. The yesterday's party seems to have gotten to me. Also, thank you for all of the DSC organization for organizing this and the party. Yeah. So first of all, before we start, do we have any sales agents here or people who have worked in sales? Please raise your hand. Nobody? Okay, that's fine. So yeah, good afternoon once more. Today, me, Lovro Matosevic, who is a machine learning engineer at Atomic Intelligence, together with my colleague Simun Sunjic, who is a senior software engineer, are going to present you our BI chat LLM system. As it was introduced, it's mostly used to empower salespeople and BI and data analysts alike. So without further ado, let's start with the agenda. First of all, a brief introduction, then we'll go through some of the challenges, and then Simun will take over and show you our proposed solution while focusing more on the technical parts of our system. Then we'll finish off with a quick demo and discuss briefly some of the future directions and challenges. The animations seem to have broken down in transport, but yeah. Okay. First of all, on the left-hand side of the slide, in the circle part, we can see some of the user-related text to SQL and SQL challenges. SQL has a steep learning curve, it's quite complex, and it takes time to both write and learn SQL, especially for sales agents who mostly come from a non-technical background. So here in the middle, we can see some of the challenges which are both user and technically related, and these include natural language ambiguities. As the presenter before discussed, natural language is ambiguous, and the same thing can be said in different manners. Next up, data is complex, there are multi-table joins, queries can get quite inaccurate, we can get join explosion. And as for the technical parts, which are of the most interest to us, these include integrating multiple data sources, so multiple databases, multiple database types, and so on. There are some context issues, especially with the complexity of the schemas. These schemas can get quite complex. There can be tens or even hundreds of tables with tens or even hundreds of columns. Yeah. Next up is error handling and data filters. Data filters are very important. As one of our colleagues who is a BI analyst explained to us, they often have to combine multiple data filters even for the same client. So yeah. As I've already mentioned, the schemas can get quite large, and in some cases, the foreign keys are missing. To conclude, there are a number of challenges, as you can see, and we'll discuss some of the ways these challenges can be solved. Next up, the first question we've asked of ourselves is, can simple retry help? On the left hand of the slide, you can see some of the most common text to SQL problems. I'm not going to go through all of those. If you want, you can take a photo. Yeah, but some of the most problematic ones are schema contradiction. This happens when the generated query has some differences from the original database schema. Next up is, attribute over analysis, and perhaps I'll say join redundancy. Join redundancy often happens. This happens when the model generates more joins than it's necessary. This is why we have multiple optimizations and such. And yeah, on the right hand of the slide, you can see a little, I don't know how to call this, an algorithm, little proposal of an algorithm, where the user asks a query, it goes through the validator, and if the check passes, everything is fine, and if it doesn't, it goes through the error handler, which either auto-corrects it or it asks for user feedback. This is like the simplest form of retry which you can implement, and it was our starting point. So to answer our question, can simple retry help? Both yes and no. It covers some of the most basic cases of these problems, but it's not a universal fix, yeah, as it always is. And now to go through some of the key points of our system. We use LLMs to generate queries. We use Retrieval-Augmented Generation, or RAG, for context understanding. We use a multi-agent architecture. We are currently experimenting with graph databases for global schema context and understanding, and also we have a user-friendly UI for visualization and reporting. And without further ado, I'll pass on the mic to my colleague Simun, who's going to present you the technical parts.
This intro, basically, when we were thinking about what we need, we were thinking, of course, about the core. We are not so much interested into showing you everything around, because there is API gateway authentication and everything, but that's not important. Important is to basically describe what we did in this core. So the lady before us talked about intention analyzer, and you saw that this can be quite complex. So when you start from the simplest approach, which is looking into user utterances, but also into kind of using regular expressions, you can solve some problems, but you will see later that it can go in multiple directions by also preventing the user to chatting too much directly with LLM or using our system to I don't know what. Other components are, of course, SQL generator. SQL generator is the most important part, which is working in a zero-shot manner, but also in multiple hop with agents. When you have more complex queries, we use some technologies around basically to decompose these queries to multiple smaller queries to basically before executing it. You have validation agent, which also includes security checkings. Of course, you need to prevent SQL injection, only allow maybe select or bit close or common expression patterns, and also try to match the SQL query with existing entities using natural language understanding, basically to get let's say, close to 100% or 100% accurate SQL query before execution. Then you have a context processor. This one is not a database. It's kind of like in-memory system, like you can think of it as a Redis or something similar, which is basically helping mostly agents to kind of adapt to user environment. So when we detect that user opened the chat session, we try to understand or pull all the metadata about that user specifically, but also metadata about his database connector out. And we hold it in a memory. So this is not too much of information, but if you basically use similarity or vector embeddings, you can basically end up with finding what's matching for that user really quickly. And then we have a coordinator, which is the most important part of agentic system when you have tools in agentic world, which is basically taking care that everything is not taking too much time, not going into deep recursions and stuff, but also tracking the progress, whether something is satisfied or not. Then you have optimization. This one is pretty important because oftentimes LLMs can generate queries which are too large or maybe too complex, which is oftentimes not necessary. When you analyze your query and you rethink few times, you see that maybe this can be simpler. I don't need to join these tables and blah, blah, blah. Maybe user doesn't need these columns and stuff like that. Then we have integration layer. So here we decided to use small language models, especially Llama models, because they showed excellent results, not only 8 billion parameters, but also the higher ones, of course, but not the vision model, because we don't need that right now. Database integration is the system around our software, where we created the plug-and-play plugins basically for various database types. So relational database are per se there, but we are planning also to integrate with BigQuery databases and cloud, of course. Monitoring integration, so not only using Grafana or system like that, Prometheus, but also taking some of the technologies which are coming nowadays, like for example, LangTrace or Langsmith, basically to detect what LLM is doing behind. And you will see, I will mention later on, some of these agentic frameworks are pretty hard to debug. Of course, external services are integration with our basically clients. The idea here, what we built is that everyone can access via API, and we are already planning some integration with popular BI tools. Cache integration, so this is used like, of course, to store the conversation history, but here you need to take care that you don't go too much into like saving everything, but you can decide to basically save, let's say, 5 rollouts of conversation just to be there in memory because it's a fast read and write. Lastly, so I mean, it's not last, but also touching the core deeply is how we are seeing our data. So PostgreSQL is used for our application because it's also built as an extendable system. It's having a lot of extensions you can turn on. It can also be a graph database, but we decided to separate that. So keep the vector similarity in Postgres and use graph database separate. We started with Neo4j, but we also find alternative, which is PuppyGraph. And PuppyGraph is capable of connecting directly to relational databases and basically from information schema extracting the DDL and converting it into graph. So why schema linking? When user asks question about their data, they rarely match exactly the column names. So that's why the naturally first thing you will do, you will go and pick up your schema from the database, because why not? It's available. Every database is providing it through information catalog. Of course, you need to understand foreign keys and relationship to basically build up on that, to build up nodes, edges on the graph. And how we did it, we embed both the user question entering the system and database schema into the same vector space to capture contextual similarity. So here we have parts that are touching that. You need to periodically update schema. This needs to be close to real time, because when someone changes something in a table with some data history or table history, you will be in a problem. Few shot are set of golden SQL queries. So golden means that that query really works. So we came up with a solution that while fine-tuning, we can basically build the data set, and from that data set we could choose a set of complex queries, set of really simple queries, and the ones in the middle. And we will use them later on for system prompting, injecting them in a prompt. But also, when user asks a question, you can match a few shot examples, like you can have them like, let's say 100, but you can extract only the relevant ones which are important for LLM. And of course, conclusion is that this really increases the accuracy of generating SQL and bridges the gap between human interaction with the bot. Now on a query generation process, intention detection is not easy. I mean, I will say a few words about it, even though I plan it later on. So you saw in previous presentation, there are techniques how you can approach. So we started with simple regular expressions, but we ended up with utterances and basically storing a lot of this similar data into database. And only if the confidence scoring after you calculate it is over 50%, then you probably can work with it. If not, you need to go to the second step, which is kind of relying on LLM, or basically trying to detect it via similarity, or relying on LLM to decide as a fallback mechanism. So this is especially important not only to grab the data or things like that, but also to direct user and also agents to which direction to go. So when you have the intent, you will extract this data, you will hold it in this context processor, and context processor will take care that this is accessible to the agents later on. Then you have system prompts. Of course, carefully crafted systems are always tricky. Depends also on a model. But after we spend some time with Llama models, we think that they are sharp enough. And the key is providing contextually relevant examples for the DDL by basically also taking care that you don't break the context window. Conversation history is something that we save in cache. As I said, we are keeping the rolling window of recent queries, and then we are strategically caching the database records that help us maintain conversation coherence. So the optimal approach is keeping, like, as I said, maybe a few of them active, because you might have, I don't know, hundreds of users online, and you need to take care of your resources as well. Chatty agents is kind of a problem, but also an opportunity. You can see a pros and cons here. So if you have chatty agents, that might mean that your system is going toward the rethinking process, so deep reasoning, but also it can happen that they fall into recursion problem. So orchestrator agent here is taking care of not letting them to go too deeply, and you need to halt the conversation. Then you have this context manager, which is centralized basically using vector stores for schema metadata and of course ready for sessions state. This approach of query optimization help us basically increase our accuracy and lower down the latency. Query optimizer is built-in generator into our SQL system. So multi-stage validation process improves query accuracy. So that process includes basically optimizing the query to maybe be smaller, faster. Let's try to use the only indexed columns. Let's discard some joins and stuff like that. This picture is something that we came up after basically concluding that some of the databases are really large. So we have like gigabytes of data in some columns. And we said we will not like embed everything, we will not copy everything because that's too much of work. Either ways, our indexing process is taking time. So we said, let's extract only high cardinal columns. So this means that you have tables where basically your data changes every day. Like it's like read-write, or doesn't have to be read-write, but the idea is that you have columns which are storing text, and you want to use full text search basically to match by exact keyword, or you will never use like or stuff like that. But the idea is to build a space which then LLM can recognize from this data that you give in a runtime that can match user question. For example, if you have some data about events, and DSC Europe is the name of the event. So if you want to match it, you will just extract it out, basically record the ID of that row, and call it as a metadata and embed it. And then you, after you synchronize all of this, you can improve your query with this data. During the query generation process, we identify some essential tools. So not only the SQL generation, there is also visualization part. Our system is capable of generating almost from anything. So we found that two-dimensional data is the simplest, but when you have multiple dimensions, you need to use like radar graph and things like that to depict it. But what's the idea is that this agent is also trying to optimize it in JSON or whatever before returning to UI, just to have a standard format basically to be accepted by the UI. On this picture, there are two examples that user often asks. So user use keyword this, usually to refer something from the history, so you need to know what this means. And also compare this with the previous year, so obviously you need timestamps, but when you compare years, not regenerating the query again. You take the same query from the context manager and try to add timestamp to it and then execute it again and then compare it. This is more on agents. So we started with LangGraph, then we went out or trying also Crew AI, but also a Microsoft solution. This image is mostly similar to Magentic 1, which is popular these weeks. The idea is to have the orchestrator and basically take care of this process and also halting the conversation when it's proper time. Now, a few more words on graphs. So basically, this approach of using graphs significantly outperforms traditional sequence-to-sequence approaches, and the system identifies in this process root node, so so-called directed acyclic graph, and it's also going like with multiple hops to nodes to construct the query. Why graphs? Because they can see like a global change in database, but also can be used to go deeper down into the process and extracting subqueries, and then maybe using union to construct multiple SQL queries and stuff like that. Multi-hop reasoning through graphs help capture so-called non-local dependencies that simple sequence models might miss. So that's the basic idea. So for example, when someone asks sales strategy of top performance, the system must understand the strategy comparison, extract the performance, and then basically attributes through multiple, collect attributes through multiple hops before constructing the query. Now, colleague will continue with the fine-tuning part.
Okay, I'm back again. As for the fine-tuning, as my colleague mentioned, we've fine-tuned the Llama 3.1 model, and we'll briefly go through some of the key points. So first of all, we did it to enhance query generation accuracy. Fine-tuning it, adapted it to our client's specific needs and the client's specific database or in data warehouse. It improves understanding of complex queries. We'll see some of the examples going forwards. As for the customization to business context, it was important to fine-tune the model and incorporate specific terminology and both the data schemas of the data schemas of our client's database. Also, it aligns the model with industry-specific language. As we'll see right now, some of the examples of these domain-specific terms include customer churn in telecom, or as was the case for one of our retailer clients, we've had terms like inventory turnover. And it was important to include all of these so our model could handle the sales agents or BI engineers' requests better. We also crafted a custom synthetic data set All of these SQL examples are hard to write by hand, so we've resorted to crafting a synthetic data set. Let's take a quick look. We used LLMs, mostly ChatGPT and Anthropic models. We've generated tailored question query pairs, specifically for our client's data warehouse. It consisted of more than 200 complex queries. We'll see one example going forwards, and 200 less complex ones in order to cover both simple lookups and more complex operational queries. Yeah. So here's the example. We won't be going through the whole SQL. If you want, you can take a picture. But as you can see, just by looking, it would be quite painful to write this by hand. This was completely generated by an LLM, validated against our client's database, and returned some of the results. Also, you can see it uses some of the complex SQL operations, such as CTEs. And the question was, which customers have shown the highest increase in average order value from last quarter to this one, and how does their current performance compare to the company average? So again, both the question and the query were generated by an LLM. Also, it was important to expand the dataset through paraphrasing, since, as we've already mentioned before, and as was already mentioned in a presentation before us, the natural language is ambiguous. The same thing can be said or asked in multiple manners. And finally, the impact it had on the model performance was significant. It improved accuracy and relevance in the query results. Also, it enhanced ability to handle varied expressions and complex queries. And now for a quick demo. I hope the video will work, since this is PowerPoint we're talking about. Okay, let me start. Nice. Okay, so basically this is our app. This is a list of chatbots. Let's create a new one. You can choose one of the existing models or upload your own through Ollama. You can choose the database type. You can also edit the database DDL, which is important, and add like comments in order for a generation to be more precise. Also, you can edit the system prompt if you need to align the model more better. You can upload your knowledge base, of course. And now, what happens when we open the chat? We get this classic interface, some of conversation starters. We can choose visualizations, or we can let the system choose it by itself, by detecting intent. Here are some of the examples of conversation starters and their appropriate queries. And now, let's prompt it. The question is, what are our top 10 customers by total sales amount? So a pretty simple question any sales agent would ask. And then we get the results in a table form. We get those top 10 customers. We get the generated SQL. We get some descriptions of our customers. We can also export it to Excel. As you can see, the list of customer names and total sales. And now let's explicitly ask it to visualize something. As you can see, we don't ask it to visualize in a specific format. It chooses a bar chart by itself. And this is how it looks, basically. Yeah. That was it for the demo. And now to briefly discuss some of the current challenges and future directions. Currently, we're ongoing model tuning for diverse data sets. We're trying to make the model better at generalization. We're looking to embed context management for complex queries, and also get better SQL accuracy and injection prevention. So basically, security type. As for the future directions, we're looking to reduce latency, either by distilling the models or some of the other techniques, by scaling and such. We're also looking to get higher precision during the query generation by fine-tuning the bigger models and so on. And we're looking to get better intention detection by perhaps using some of the techniques which were mentioned in the presentation before. And that would be it. I would like to thank you all for your attention, and yeah.
Thank you very much. This is for you and for your colleague. Well, thank you very much again, and I hope everybody interested can find you.
If you have any questions, you can ask after the presentation. Thank you once again.
Thank you.